Hey everyone, so in this video I'm going to go through how to set up your LabVIEW for Lab 3. The first thing that you're going to want to go ahead and do is go to your assignments and then Lab 3 and download this trajectory VI right here. So you're going to just need to download that, extract it, and then put the file in your controls lab folder. Alright, so I went ahead and opened up my Lab 1 LabVIEW and saved it as a different name to make the Lab 3 LabVIEW. The first thing that we're going to do is add our turn on voltage to the H bridge. So to do that, you're going to just go up here. Should be the last connection that you have. Right click to create a constant, and you're going to just set that to be whatever the turn on voltage that you have for Lab 1 that you found that the motor starts to turn at. What that does is make sure that any commands that you put out to the motor are a minimum of that turn on voltage, which basically just makes sure that you're putting out a command large enough to overcome the friction to where you're actually going to do something to your motor, and this is going to really help the performance of your system. Next thing that we're going to do is add the trajectory sub VI. So down here in my sine wave generator, first I'm just going to rename these since we're going to add another case. So I'm going to name this one square. I'm going to name the regular case just sine. And then I'm going to go ahead and add another case after and just call it trajectory. And then I'm going to go ahead and delete that because we are going to need to make a new one. So I'm going to right click in here, select a VI, and right here is the trajectory SP21, which you should download from the course website. And put it in here. As always, if you click it, do Control H, it will show you what the different connections that it wants are. So your position, that's going to be your encoder 0, which should be the wire going to your error here. So I'm just going to drag this down, poke it through the side, and then add it to the position. The command out, which is this top right one, I'm going to just run right here into the output that goes to our magnitude and phase offset. And then we have these flags right here. So we're going to just put these into the side of our case structure here, which is going to be angry at first, but we'll fix that in a second. So now that we have those on the side, going to right click on the side of our while loop, which is the gray box right here, and we're going to need to add some shift registers. We're going to need 2 of them. Right click and just add shift register, and then just connect these straight across into the sides of the blue wires. Should see that they no longer show as broken. Right here you can still see that we have the white boxes, which means it still needs a case fixed. So if you look at the square wave right now, there's nothing going out, so you can just drag these across. And same thing for the sine wave, just drag these across and you should be good to go. So now we need to redo a way to select which case that we want. So I'm just going to go to the front panel, right click, not select a control, right click, search. I'm just going to look up enum. Doesn't really matter which one, but you got the system enum right here. I'm just going to call that generator. And then same thing as the first lab, just going to right click, properties, and then insert under edit items, the name matching the back panel. It is case sensitive, so make sure you get that right. Alright, so now that we have our selector, I'm just going to right click it and do find terminal and put it right here. And you're just drag this wire into the left side of the green there, and as you can see, all of our cases are now black, so we're good to go there. So now we're going to set up the ability to do the PID controller. Just to be clear, I'm going to rename my proportional just PID, and then switch back over here our controller type, right click, properties, again under your items. I'm just going to change this proportional to PID. So now we have that, and again it's black, so we're good. So to do our integral and derivative gain, the easy way of figuring out what the integral and derivative of our error are is to use the math tool higher order that we did before in lab 2. So I'm just going to do right click, select a VI, and it should be in Tools, Math Tool Higher Order. And again, you can see top right, we have our different things that we're going to need. So time, I'm just going to grab our elapsed time from over here, put it in there. Data, we are wanting our error, so I'm just going to grab this right here and bring it in. We want to add controls for points to differentiate over and points to integrate over. So those two blue on the bottom left, I'm going to create controls for. Name is fine. So there's those. If we decide we wanted to change the number of points we were integrating or taking the derivative over like on the fly, we need to be able to reset this. So I'm just going to go ahead and create a control for that reset. And then you can see on the right side, we have our outputs for integral, first derivative, second derivative. So integral, going to drag there. First derivative, going to put like right there. All right. So now we just need to multiply these integral and derivative by their gains. So I'm going to just copy this multiplication sign. And put our wires straight into the top. Going to right click on the bottom, do create control because we want to be able to change it from the front panel. Name that KI gain. And same thing here. Right click. All right. And then our total command that we're going to output to our H bridge is going to be the summation of those three. So I'm going to get rid of this wire right here and add some additions. And just add all these together. And so right there is our total command that we are putting out to the system. So the next thing that you can do, which the instructions ask you to, is to add the ability to estimate the motor shaft velocity. And the way that you're going to do that is the same way as Lab 2, just using the Math Tool Higher Order. For both of those Math Tool Higher Orders, you're going to want to potentially use like a Butterworth filter to get that data looking a little bit better. But that's up to you. Anyway, so the last thing that our instructions ask us to do is to add a front panel display graph of the desired motor position, the actual motor position, and the signals being sent to the analog outputs. So to do that, I'm going to just take the easy way and copy what's already here. So I'm just going to copy this plot, and it doesn't really matter where you put it. I'll just put it on this tab and then have to rescale everything. All right, so encoder graph 2. If we look right here, and then we are going to need to copy this guy right here, cluster. And since we have 3 items, we need to double click on that cluster and put it to 3 elements. And then the last thing, we need to put an array into this cluster of our data so that it will plot it. So I'm just going to right click, go to array, and just do build array. Drag it down to where it's 3 items long, and then put that into the side. So our first data item we want is our desired position. So I'm going to put that right there. And then we want our, I believe, actual position. So that is this wire right here. And then the last thing is the command out. Since our command is between -1 and 1, and all these are going to be much bigger, I'm just going to add a little, a multiplication of block so that we can add like a scalar to where it's more visible. So on the bottom, I'm just going to right click, create a constant, just scale it by 100. And then the last thing is to put our command out going into it. So that pretty much wraps up our back panel. You still are going to have to go through yourself and add all your wires into how to save things, but you should know how to do that by now. Just look at that Lab 3 assignment and it will tell you exactly what you might want to save for your analysis. So if you look on the front panel, you can see we have all the different things that we added here. Let me try and grab all of them at once. and I'm just going to make them all black so we can actually see them. All right, so our Ki gain, that's our integral gain, I'm just going to put here. Kd is our derivative gain. The values for what Kp, Ki, and Kd are, for goal number 1, where you're getting like the qualitative feel of the flywheel, we give you gains to test. For the tuning of the controllers, you're going to have to decide what those gains are. For the points to integrate over and points to differentiate over and our reset, they can all be kind of put together. The lab instructions say to do 30 points to integrate over and 3 to differentiate over. And then we're using our PID controller for this lab exclusively, so you don't need your deadband or your bang bang at all, but I'm just going to leave it there. And then over here on the left side, your frequency, the lab instructions tell you when you're trying to tune the square wave what to do for magnitude and frequency. If you're using your trajectory generator, you want to set your magnitude to 1. So that's pretty much it for the Lab 3 VI. Only other things you might have to do on this side is change your scale of your axes if you don't like it auto-scaling, but that's kind of up to you. So anyway, that's it.